I love the ratio test. It's a lot of fun. Algebra lover's dream. Let's move on. I want to find if this series converges or diverges. And just to recap, if you take the absolute value, just in case it's alternating, and you take the next term divided by the current term, and the limit, as you approach infinity, is less than 1, converges absolutely. Greater than 1, diverges, equals to 1, inconclusive. Can't tell. So let's do it. I want the limit as n approaches infinity. This is such a practical test. We'll use this a lot later. This is the one we use later when we're dealing with Taylor polynomials. It's fun. You'll love it. All right. I need the next term, and the next term would be n plus 1 in the place of all my n's. And then n plus 1 there. All right. Divided by. And then the current term, n to the n over n factorial. Yeah, n factorial. There we go. And absolute value on that, although this will never be negative because it's not alternating. So if you want to leave the bars off, it's not a huge deal right now, but I'm going to put them in there. So let's continue with the algebra. A lot of exponent rules that float around in this. N approaches infinity. Let's use the bars. All right, numerator of the numerator is n plus 1 to the n plus 1. So this is really n plus 1 to the n times n plus 1 to the 1. Put it for fun. All divided by n plus 1 factorial. We can break that down a little bit. We'll call it n plus 1 times n factorial, because if you multiply these together, you'd have n plus 1 factorial. And then divided by, I put times instead, and we're going to flip this one over. So n factorial over n to the n. All right, there we go. Keep going. We can cancel some stuff out, and the stuff we're going to cancel out is going to become obvious, right? Here, 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 and here. And that leaves us with, and we'll put it on the next line, the limit as n approaches infinity of absolute value, n plus 1 to the n over n to the n. Now you might look at that and say, well, the numerator is a little bit bigger. I agree. Okay, but what's the limit? What is the limit? All right, so basically, all things considered here, this plus 1 isn't going to make a big difference in the process of doing this. And so you almost have pretty much the same thing in the numerator and the denominator. You have n to the n in the denominator, n plus 1 to the n in the numerator. And so this limit is equal to 1. What a letdown. The test is inconclusive. And let's be specific. The ratio test. You let me down this time, ratio test, is inconclusive. There we go. Now again, you can make the argument, numerator is bigger than the denominator. I hear you, but the limit itself is equal to 1. So this is inconclusive.